Hello everyone, this is your tutor AB. Today we're going to be solving a problem from the May 2023 IB Physics HL examinations. This is a paper 2 problem. Let's get started. A cell of negligible internal resistance and electromotive force EMF 6 volts is connected to 3 resistors R, P and Q. So here they've given us some diagram. R is an ohmic resistor. The IV characteristics of P and Q are shown in the graph. So here they've given us a graph. The current in P is 0.4 amperes. Show that the current in Q is 0.45 amperes. So let's get started. So we know the current in P is 0.4 amperes. So let's find that on this graph. So when P has a current of 0.4 amperes, it has a voltage difference of 1.4. Okay, so that means across P there's a voltage difference of 1.4, and so we know there is supposed to be a total electromotive force of 6 volts. So the voltage difference across Q must be 6 minus 1.4. So V across Q is 6 minus 1.4, which is 4.6 volts. Okay, so when Q has a voltage difference of 4.6, so let's find that on this graph, the current that passes through Q is, if we put a line, 0.45 amperes. So from the graph, Q has current 0.45 amperes. So simply all we did was derive this number from the usage of the graph and numbers. So calculate the resistance of R. So we know the formula is V is equal to IR, a very basic formula. So we know that V over I is equal to R. So they are calculating the resistance of R. So what is the voltage drop, voltage difference across R? That's 1.4. And what is the current that passes through R? Well, we know the current that passes through Q is 0.45, which then splits there and there, one of them getting 0.4 amperes. So the other one must be getting 0.05 amperes. So R is getting a current of 0.5 amperes, 0.05 amperes. That's 0.45 minus 0.4 is equal to 0.05. So then putting this in my calculator, I get the resistance of R, which will come out to be 28 ohms. Okay, third part. Calculate the power dissipated in the circuit. Now there are a few formulas for power, but the most simple would be P is equal to IV. So power is equal to current. The total current in the circuit is 0.45 times by the total voltage in the circuit, which is 6. So I get power is equal to 2.7 watts. And part B, resistor P is removed. Suggest without any calculations the effect of this on the resistance of Q. Okay, so basically in the circuit, let me just erase everything so it's easy for you to see. In the circuit, you have a parallel inside of a series connection, a parallel circuit connected to a series connection. So basically, when I remove P, this parallel connection no longer exists. So the overall resistance in the circuit increases. As a result, the current that passes through Q will decrease. So let me write this. When P is removed, there is no longer that alternate parallel connection, so the overall resistance increases. And we know from V is equal to IR, right? When we know from V is equal to IR, I is inverse to 1 over R. So current that passes through the circuit decreases. Now, using the graph, we can find out how this affects. So when the current that passes through Q is decreasing, right? When the current that passes through Q is decreasing, the voltage difference across Q is also decreasing from this graph. And we know because V and R are directly proportional, as the as the voltage across Q decrease, resistance of Q decreases as well. So to simply wrap it up just in words, this is how it works. When I remove P, I remove this alternate pathway for this parallel connection, so the overall resistance in the circuit is increasing. I know from V is equal to IR that the current is inversely proportional to the voltage, and so I know that the resistance is inversely proportional to the current, and so when the resistance increases, the current that passes through the circuit decreases. And from this graph, when I see that the current that passes through Q is less, the voltage across Q is also less. And from again V is equal to IR, there's a direct proportionality between V and R, so when voltage is less, resistance across Q also decreases. Okay, thank you for watching. Please like and subscribe. If you have any questions, leave it down below and I'll answer it as soon as possible. Thank you for watching.